March 2, 1945, Oranienburg, Germany. Test pilot Erwin Ziller climbs into the cockpit of one of the most radical aircraft ever conceived. No fuselage, no tail, just a smooth black wing sweeping back at 32 degrees, powered by two Jumo 004 turbojet engines. The Horten Ho 229, Hitler's secret weapon. A jet-powered flying wing designed to strike London and return without being intercepted. An aircraft so advanced that modern engineers still marvel at its design 75 years later. Ziller advances the throttles, the jets spool up, the aircraft accelerates down the runway and lifts smoothly into the air. For 12 minutes, everything is perfect. The handling is responsive. The speed is phenomenal. This aircraft could change the war. Then one engine fails. The flying wing begins an uncontrollable roll. Ziller fights the controls. The aircraft plummets. It impacts the ground at high speed. Ziller dies on impact. The Ho 229 program dies with him. But the story of this aircraft, and the two brothers who designed it, is about far more than one fatal crash. It's about visionary engineering decades ahead of its time. It's about desperate innovation in a dying regime. It's about technology so advanced that when American forces captured the prototype, they kept it secret for decades. It's about a flying wing that shouldn't have been possible in 1945, but was. An aircraft that would influence jet design for generations. And two brothers who dreamed of flying wings while the Third Reich burned around them. This is the story of the Horten Ho 229, the jet fighter that was simultaneously Nazi Germany's last hope and a glimpse into the future of aviation. A machine born from brilliance and desperation in equal measure. Welcome to the race for the jet age, where innovation met ideology, where aerodynamics met desperation, and where two brothers created something that would haunt aviation history for decades. Before there was the Ho 229, there were two brothers obsessed with flying wings, Reimar and Walter Horten. Their story begins not with Nazi ideology or military ambition, but with pure aeronautical passion. Reimar Horten was born in 1915, Walter in 1913. They grew up in Bonn, Germany, during the chaotic years after World War I. Germany was economically devastated, politically unstable, and prohibited from building military aircraft under the Treaty of Versailles. But the treaty said nothing about gliders. The German youth glider movement of the 1920s and early 1930s was where the Horten brothers learned to fly. They weren't alone. Many future Luftwaffe pilots and aircraft designers started in gliders. But while others moved on to conventional powered aircraft, the Hortens became obsessed with a radical idea: the flying wing. Most aircraft have a conventional layout, a cylindrical fuselage holding the cockpit, payload and fuel, wings extending from the sides to generate lift, a tail section at the rear for stability and control. This configuration has worked since the Wright brothers. It's intuitive, it's stable, it's conventional, but it's also aerodynamically inefficient. The fuselage generates no lift, it's just dead weight and drag. The tail section exists only to stabilize the aircraft. More weight, more drag. From a pure efficiency standpoint, the conventional aircraft wastes energy, overcoming its own structural inefficiencies. A flying wing eliminates these problems. The entire aircraft is a wing. Everything, cockpit, engines, fuel, payload, is integrated into the wing structure. No fuselage, no tail, just a wing. The advantages are compelling. Reduced drag means higher speed or better fuel efficiency. Less structural weight means greater payload capacity. Smaller radar cross-section means better stealth characteristics, though in the 1920s, radar didn't exist yet. But flying wings have serious problems. Stability is a nightmare. Without a tail, the aircraft has no natural stabilizing surfaces. It's inherently unstable, requiring constant pilot input or advanced automatic control systems. Controlling pitch and yaw without conventional control surfaces is extraordinarily difficult. And designing a wing structure strong enough to contain everything while maintaining proper aerodynamic shape is a massive engineering challenge. Despite these problems, the Horten brothers believed flying wings represented the future of aviation. They were right, but they were also 40 years too early. In 1931, when Reimar was just 16 years old, the brothers designed and built their first flying wing glider, the Ho Y. It was crude, fabric stretched over a wooden frame, basic flight controls, no sophistication. But it flew. More importantly, it flew well enough to convince the brothers they were onto something. Over the next decade, they would design and build a series of increasingly sophisticated flying wing gliders. The Ho 2, the Ho 3, the Ho 4. Each iteration solved more problems. Better aerodynamic shaping, more refined control systems, improved stability through careful center of gravity positioning and control surface design. By the late 1930s, the Horten brothers had become respected figures in German aviation circles. Their gliders won competitions. Their designs were discussed in aeronautical journals. But they remained hobbyists, building aircraft in their spare time with limited resources. Then came World War II, and everything changed. When war broke out in September 1939, both brothers were called up for military service. Walter became a fighter pilot, flying Messerschmitt Bf-109s in combat. Reimar, due to poor eyesight, was assigned to transport aircraft. But their reputation as innovative aircraft designers preceded them. The Luftwaffe was interested in unconventional designs. Hermann Göring, head of the Luftwaffe, encouraged experimentation. If you had a radical idea that might provide an advantage, you could get resources to develop it. The Hortense flying wing concept qualified. In 1943, they were given permission to develop a powered flying wing fighter. Not as a primary project, the Luftwaffe had plenty of conventional fighters in development, but as an experimental program, a what-if project. What if you could build a high-performance fighter with dramatically reduced drag? The brothers designed the Ho 7, a powered flying wing with a single-piston engine. It flew in 1944 and demonstrated impressive performance. But by 1944, Germany's situation was desperate. The Luftwaffe was being decimated by Allied fighters and bombers. Fuel was scarce. Experienced pilots were dying faster than they could be replaced. Conventional piston engine fighters weren't enough anymore. Germany needed a technological leap. They needed jets. And this is where the story of the Ho 229 truly begins. Because in 1943, Hitler made a declaration that would drive German aircraft development for the rest of the war. A declaration that was simultaneously visionary and delusional. A declaration that would give the Horten brothers the opportunity to build their ultimate flying wing. Hitler called it the 1,000-1,000-1,000 requirement. He wanted a bomber that could carry 1,000 kilograms of bombs, fly 1,000 kilometers, and reach 1,000 kilometers per hour. 1,000 kilograms. 1,000 kilometers. 1,000 kilometers per hour. No aircraft in the world could meet those specifications in 1943. But the Horten brothers thought their flying wing design could. If they could mate their aerodynamically efficient flying wing concept with the new turbojet engines being developed, they might be able to build an aircraft that met Hitler's impossible requirements. They proposed the Ho 9, which would later be redesignated the Ho 229, a jet-powered flying wing fighter bomber. Fast enough to outrun Allied fighters, long-ranged enough to strike England and return, efficient enough to operate in Germany's fuel-starved logistics nightmare. The Luftwaffe was skeptical but desperate. They approved the project. The Horten brothers were given resources, materials, and priority. Build a prototype, make it fly, prove the concept, and incredibly they did. The Horten Ho 229 was not a conventional aircraft with some modifications. It was a fundamentally radical design that required solving problems no one had solved before. Let's start with the most obvious feature, the shape. The Ho 229 was a pure flying wing with no fuselage and no tail. The wingspan was 16.8 meters, about 55 feet. The wing swept back at 32 degrees. The entire aircraft, from the pilot's perspective, was just a wing extending in both directions. This wasn't just aesthetically radical, it was aerodynamically revolutionary for 1944. Swept wings provide advantages at high subsonic speeds by delaying the onset of compressibility effects, the aerodynamic problems that occur as you approach the speed of sound. But in 1944, swept wing theory was still developing. German aerodynamicist Adolf Busemann had presented swept-wing research in 1935, but practical application was limited. The Horten brothers incorporated a 32-degree sweep, not primarily for high-speed performance, though that was a benefit, but to solve the stability and control problems inherent in flying wings. The sweep moved the center of lift relative to the center of gravity in ways that improved pitch stability. It was elegant engineering. The airfoil section varied across the span. Thicker at the center, where the cockpit and engines were located, thinner toward the wingtips. This wasn't unusual. Many aircraft use varying airfoil sections, but integrating everything into a wing structure while maintaining proper aerodynamic properties was extraordinarily difficult. The structure itself was remarkable. The frame was built from steel tubing welded together to form a rigid center section. Wooden ribs and spars extended outward to form the wing structure. The skin was a mixture of plywood panels bonded together. This mixed construction, steel, wood, plywood, was typical of late-war German aircraft. By 1944, aluminum was scarce. Priority went to aircraft already in production. Experimental designs used whatever materials were available, but this actually proved beneficial for the Ho 229. The wooden construction, combined with the smooth, organic shape, would later be discovered to have remarkable radar-absorbing properties. This wasn't intentional. The Hortens weren't trying to build a stealth aircraft. Radar was still primitive in 1944, and stealth technology as a concept didn't exist. But the combination of wood construction, iron oxide-based adhesives, and smooth contours accidentally created an aircraft with a significantly reduced radar cross-section. Decades later, when Northrop was developing the B-2 stealth bomber, itself a flying wing, engineers would study the Ho 229 and marvel at how the Horten brothers had inadvertently discovered stealth principles. But we're getting ahead of the story. In 1944, the Hortens were focused on making the aircraft fly, not making it invisible to radar. The control system was ingenious. Without a tail, the Ho 229 couldn't use conventional elevators for pitch control or a rudder for yaw control. Instead, the Hortens used elevons, control surfaces on the trailing edge of the wing that could move together or differentially. When both elevons moved up, the aircraft pitched up. When both moved down, it pitched down. When one moved up and the other down, the aircraft rolled. By combining roll and a slight amount of drag-induced yaw, the pilot could turn the aircraft without a rudder. This sounds simple in theory. In practice, it required extraordinarily precise aerodynamic calculations and careful mechanical design. The control surface sizes, positions, and deflection angles all had to be exactly right, or the aircraft would be unflyable. The Hortens got it right, or close enough. The power plant consisted of two junkers, Jumo 004 turbojet engines. These were the same engines used in the Messerschmitt Me 262, Germany's operational jet fighter. Each engine produced about 1,900 pounds of thrust, modest by modern standards, but revolutionary in 1944. The engines were mounted inside the wing, one on each side of the center cockpit section. The intakes were smooth, blended into the wing's leading edge. The exhausts exited at the trailing edge. Everything was integrated as cleanly as possible to minimize drag. But jet engines in 1944 were temperamental beasts. The Jumo 004 had an operational lifespan of about 25 hours before it needed major maintenance or replacement. They were prone to flameouts, compressor stalls, and mechanical failures. They consumed fuel at an alarming rate, and they required careful handling. Advance the throttle too quickly, and you could damage the engine. For an already challenging flying wing design, adding unreliable early jet engines compounded the difficulties. But there was no alternative. Piston engines couldn't provide the speed and altitude performance required. Jets were the only option. The cockpit was surprisingly conventional, considering how radical the rest of the aircraft was. The pilot sat in a pressurized compartment in the center section, just forward of the wing's leading edge. Visibility was good. The smooth nose section provided unobstructed forward views. Instruments were standard Luftwaffe equipment. The control stick and rudder pedals operated conventional mechanical linkages to the control surfaces. The landing gear was tricycle configuration, nose wheel and two main wheels. This was somewhat unusual for German aircraft of the period, which typically used tailwheel configurations. But for a flying wing, tricycle gear made ground handling much easier and improved forward visibility during takeoff and landing. Armament for the production version was planned as 4 Mk, 103 30mm cannons mounted in the wing roots. With a rate of fire of 400 rounds per minute and devastating hitting power, 4 Mk-103s would make the Ho 229 a formidable fighter. The aircraft could also carry 2 1,000-kilogram bombs internally for the bomber role, fitting Hitler's requirement exactly. The estimated performance specifications were impressive, even by modern standards. Maximum speed, over 900 kilometers per hour. Service ceiling, 15,000 meters. Range, over 1,000 kilometers. Rate of climb, superior to any Allied fighter. If these specifications could be achieved, the Ho 229 would be the most advanced combat aircraft in the world. But specifications on paper and actual performance are different things. The only way to know if the Ho 229 would work was to build it and fly it. Construction of the first prototype, designated Ho 9V1 because it was initially the 9th Horten design, later redesignated Ho 229, began in 1944 at a workshop in Göttingen. Resources were limited. The Horten brothers worked with a small team of technicians and craftsmen. Progress was slow but steady. By late 1944, the V1 prototype was complete. But there was a problem. They didn't have jet engines. The Jumo 004s were in high demand for the Me-262 program, and getting engines for an experimental flying wing was difficult. So the V1 flew as a glider first. In December 1944, towed aloft by a conventional aircraft, the unpowered Ho 229 V1 made a series of test flights, and it flew beautifully. The handling was responsive, the stability was acceptable, the control system worked, the basic aerodynamic concept was validated. The Hortens had proven the flying wing configuration could work. Now they needed to prove it could work with jet engines. The V2 prototype, the first jet-powered version, was completed in early 1945. This time, they had engines. 2 Jumo 004s were installed, tested, and declared ready. The V2 would be the proof of concept. The aircraft that would demonstrate the Ho 229 could meet its performance goals. Test pilot Erwin Ziller was selected for the first flight. Ziller was experienced. He'd flown numerous experimental aircraft and was familiar with the challenges of new designs. If anyone could coax the Ho 229 into the air and back down safely, it was Ziller. February 2, 1945. Oranienburg Airfield, north of Berlin. The Ho 229. V2 sat on the runway, black against the winter landscape. Ziller conducted his pre-flight checks. The ground crew cleared the area. Ziller advanced the throttles. The jets spooled up with their characteristic whine. The aircraft began rolling. It accelerated rapidly. Jet acceleration was much more powerful than piston engines. At about 150 kilometers per hour, Ziller rotated and the Ho 229 lifted smoothly into the air. The first jet-powered flying wing was airborne. For the next hour, Ziller put the aircraft through initial tests. Basic handling checks, gentle turns, altitude changes, everything performed as expected. The Ho 229 was stable, responsive, and fast, very fast. Even at partial throttle, the aircraft was faster than most piston fighters at full power. Ziller landed successfully. The first flight was declared a complete success. The Horten brothers were ecstatic. The Luftwaffe observers were impressed. This radical design actually worked. Over the next month, Ziller made several more test flights. Each one pushed the envelope slightly further. Higher speeds, tighter turns, more aggressive maneuvers. The Ho 229 handled it all. Performance estimates were being validated. The aircraft was proving to be as good as the Hortens had promised. Then came March 2, 1945, the flight that would end the program. March 2, 1945, dawned cold and clear over Oranienburg. Perfect flying weather. Erwin Ziller arrived at the airfield for what was scheduled to be a routine test flight, the 7th flight of the V2 prototype. The flight plan was straightforward. Take off, climb to altitude, conduct some handling tests, demonstrate the Ho 229 for some visiting Luftwaffe officials, then land. Expected duration, about 30 minutes. Nothing unusual, nothing risky. Ziller conducted his pre-flight walk-around. The ground crew had reported no mechanical issues. Both Jumo 004 engines had been inspected and cleared for flight. Everything looked good. At approximately 10 a.m., Ziller climbed into the cockpit. He strapped in, conducted his cockpit checks, and signaled ready for engine start. The ground crew started the engines using external starter motors. The Jumo 004s required external power to begin the starting sequence. The first engine started normally. The turbine spooled up, reached idle RPM, and stabilized. The second engine followed. Both engines showed normal temperatures and pressures. Ziller advanced the throttle slightly, checking engine response. Everything nominal. He released the brakes. The Ho 229 began rolling forward. The tricycle landing gear made ground handling easy, much easier than tailwheel aircraft that required careful rudder work to stay straight. Ziller taxied to the runway threshold. Air traffic control cleared him for takeoff. Ziller aligned with the runway centerline and smoothly advanced both throttles to takeoff power. The jets responded with their characteristic surge of thrust. The Ho 229 accelerated rapidly down the runway. At approximately 150 km per hour, Ziller eased back on the stick. The nose lifted. The main gear left the ground. The Ho 229 was airborne. Ziller retracted the landing gear. The gear doors closed smoothly, cleaning up the aircraft's aerodynamic profile. He continued the climb, maintaining runway heading initially, then banking into a gentle turn to the left. Everything was normal. The engines were running smoothly. The flight controls felt responsive. Airspeed was building nicely. This was going to be another successful test flight. For about 12 minutes it was. Ziller climbed to approximately 800 meters, about 2,600 feet. Not high by jet fighter standards, but adequate for the planned handling tests. He leveled off and began a series of turns, rolls, and other maneuvers to demonstrate the aircraft's capabilities to the observers on the ground. The Ho 229 performed beautifully. Rolls were crisp, turns were tight. The flying wing was proving to be not just flyable, but genuinely agile. One observer on the ground would later describe watching the black wing knife through the sky and thinking it looked like something from the future. He was right. But that future was about to be violently interrupted. At approximately 10:12 a.m., 12 minutes into the flight, one of the Jumo 004 engines failed. Post-crash investigation would determine it was the right engine, though from the ground, observers couldn't tell which one had quit. They just saw the Ho 229 suddenly yaw sharply to one side. Engine failures in twin-engine aircraft are a known emergency, but they're manageable. Standard procedure: identify the failed engine, apply opposite rudder to counter the asymmetric thrust, reduce power on the good engine to reduce asymmetry, and set up for an emergency landing. Pilots practice this scenario repeatedly in training. But the Ho 229 didn't have a rudder. The asymmetric thrust from one working engine and one dead engine created a powerful yawing moment. In a conventional aircraft, the pilot would use the rudder to counter this. But the Ho 229's control system relied on elevons and drag-based yaw control. It wasn't designed for the extreme asymmetry of a complete engine failure. Ziller tried to compensate. He likely reduced power on the remaining good engine, standard procedure to reduce asymmetry. He probably applied opposite aileron to counter the roll induced by the yaw. But the aircraft was entering an uncontrollable situation. From the ground, observers watched the black flying wing begin to roll. The roll rate increased. The aircraft's nose dropped. Ziller was fighting for control, but the aerodynamic forces were overwhelming his inputs. The Ho 229 entered a spin, or something like a spin. Spinning a flying wing is aerodynamically complex and poorly understood even today. The aircraft rotated rapidly, nose down, losing altitude quickly. Ziller had options, theoretically. He could have attempted to restart the failed engine, though restart procedures in flight were unreliable with early jets. He could have tried to bail out, though the rotation rate might have made escape impossible. Or he could fight for control and attempt to recover. He chose to fight for control. For perhaps 30 seconds, Ziller struggled with the aircraft. Some witnesses reported seeing the rotation rate slow briefly. Perhaps he was making progress. But the Ho 229 was too low. There wasn't enough altitude to complete a recovery, even if one was possible. At approximately 10:13 a.m., the Horten Ho 229 V2 impacted the ground at high speed approximately 2 kilometers from Oranienburg airfield. The impact was catastrophic. The wooden structure disintegrated on contact. Both Jumo 004 engines were torn from their mounts. The fuel tanks ruptured and ignited. Erwin Ziller died instantly. He was 34 years old. Emergency crews rushed to the crash site, but there was nothing they could do. The Ho 229 V2 was completely destroyed. Only fragments remained. The wreckage burned for hours. The cause was clear: asymmetric engine failure and inability to control the aircraft with only one engine operating. But the question was this a fundamental design flaw, or could it be fixed? The investigation that followed examined every aspect of the flight and crash. The engine that failed was removed from the wreckage and analyzed. The failure was traced to a fuel system problem, not unique to the Ho 229 installation, but a known issue with early Jumo 004 engines. The engine hadn't failed because of anything the Hortens had done wrong. It had failed because early jet engines were unreliable. But the inability to control the aircraft after the engine failure was a design issue. The Ho 229's control system, optimized for symmetric flight, couldn't handle the extreme asymmetry of one engine out. Some engineers argued this could be fixed with control system refinements and better training. Others argued it was an inherent limitation of the flying wing configuration. We'll never know which assessment was correct because the program died with Ziller. Hermann Göring ordered the Ho 229 program to continue. A third prototype, the V3, was already under construction and nearly complete. But by March 1945, Germany was collapsing. Resources were non-existent. Oranienburg airfield was under threat from advancing Soviet forces. The priority was keeping operational fighters in the air, not developing experimental aircraft. The V3 prototype was evacuated from Oranienburg and moved to a secret workshop in Thuringia. Work continued, but progress was slow. There were no engines available, materials were scarce. The technicians were being pulled away for more urgent tasks. By April 1945, work on the Ho 229 had effectively stopped. The dream of the jet-powered flying wing was over. Or so it seemed. April 14, 1945. American forces from the U.S. Third Army's 8th Corps advanced into Thuringia, deep in central Germany. The speed of the American advance surprised even the Americans themselves. German resistance was collapsing faster than anticipated. Intelligence officers accompanied the combat units, tasked with locating German research facilities, weapons programs, and advanced technology. The Allies knew Germany had been developing jet aircraft, rockets, and other advanced weapons. Capturing these technologies and the scientists who created them was a high priority. Near the town of Friedrichroda, American troops discovered a concealed workshop in a forest. Inside, they found something extraordinary, an almost complete aircraft unlike anything Allied intelligence had seen before. No fuselage, no tail, just a smooth, swept wing with two large openings where engines would be mounted. The Ho 229 V3 prototype. Also discovered were design documents, technical drawings, performance calculations, and photographs of the previous prototypes. The intelligence officers immediately recognized the significance. This wasn't just another German experimental aircraft. This was something fundamentally different, something that represented a potential leap in aviation technology. The V3 prototype was carefully disassembled and crated. The documents were collected and catalogued. Everything was shipped to the United States under tight security. The Ho 229 was classified secret and its existence was not publicly disclosed. Why the secrecy? Several reasons. First, the Americans didn't want the Soviets to know about the Ho 229. The alliance was already fracturing. Within months, it would become the Cold War. Any technology that might give an advantage was carefully guarded. The flying wing concept was too valuable to share. Second, American aircraft manufacturers were interested in the Ho-229's design. Northrop Aircraft had been working on flying wing designs since the 1930s. Jack Northrop, the company's founder, was obsessed with flying wings for the same reasons the Horten brothers were: aerodynamic efficiency. But Northrop's designs had been conventional-powered aircraft. A jet-powered flying wing was still theoretical. The Ho-229 proved it was possible, and American manufacturers wanted time to study the design, understand its innovations, and potentially incorporate them into American aircraft without foreign competition, knowing what they'd learned. Third, there were concerns about public perception. Germany had been developing advanced technologies throughout the war: jet aircraft, ballistic missiles, advanced submarines. The Ho-229 was another example. If the public learned that Nazi Germany had been this close to deploying a jet fighter more advanced than anything the Allies had, there would be uncomfortable questions about Allied technology development and intelligence failures. So the Ho-229 disappeared into the classified world. The V-3 prototype was initially sent to Wright Field in Ohio, where the Air Technical Intelligence Center was located. German aviation experts, including some who had worked on various Luftwaffe programs, were brought to the United States under Operation Paperclip. They were interrogated about German aviation technology, including the Ho-229, but the Horten brothers weren't among them. Reimar Horten was captured by Allied forces but was considered too junior to be of interest for Paperclip. Walter Horten had survived the war and remained in Germany. The brothers were briefly separated during the chaos of post-war Germany. Without the designers available for consultation, American engineers had to reverse engineer the Ho-229 from the physical prototype and the captured documents. This proved challenging. Some of the design decisions the Hortens had made weren't obvious from examination alone. The aerodynamic calculations were complex. The structural load paths weren't immediately apparent. Wind tunnel testing was conducted. The V-3's airframe was studied in detail. Performance predictions were made based on the captured data and American understanding of jet engine performance. The conclusions were sobering. If the Ho-229 had been deployed operationally with reliable engines, it would have been extremely difficult for Allied fighters to intercept. Its top speed would have exceeded 600 miles per hour, faster than any Allied piston fighter and comparable to early Allied jets that weren't yet operational. Its range would have allowed strikes deep into Allied territory. Its small radar cross-section would have made it difficult to detect with the primitive radar systems of 1945. But the key phrase is, if it had been deployed. The Ho-229 was a prototype. Only 2 had flown, and 1 had crashed fatally. The third was never completed. There was no production infrastructure. There were no trained pilots beyond the test pilots. There were no operational doctrines for how to employ flying wing fighters. The Ho-229 was a technological achievement, but it wasn't a war winner. Germany's defeat was driven by strategic factors: overwhelming Allied industrial capacity, manpower advantages, logistical superiority, and the Soviet steamroller from the east. A handful of advanced fighters, however impressive, couldn't change those realities. Still, the technology was valuable. American engineers incorporated lessons from the Ho-229 into subsequent flying wing research. Jack Northrop's company continued developing flying wings through the late 1940s and early 1950s. The YB-49, an experimental flying wing bomber, flew in 1947. It was larger than the Ho-229 and powered by 8 jet engines, but the basic configuration was similar: swept wing, no tail, jet propulsion. The YB-49 program was eventually cancelled due to stability and control issues, many of the same problems the Hortens had grappled with, but the research continued. Northrop remained convinced that flying wings represented the future of aviation. Decades later, that conviction would be validated. The B-2 Spirit stealth bomber, which entered service in 1997, is a direct descendant of the flying wing concept pioneered by the Horten brothers and Jack Northrop. The B-2's designers studied the Ho-229 extensively. Some of the aerodynamic solutions the Hortens discovered in the 1940s were incorporated into the B-2's design. In 1950, the Ho-229 V-3 prototype was moved to the Smithsonian Institution's storage facility. It remained there, largely forgotten, for decades. Occasional researchers would request access to study it, but public knowledge of the aircraft was limited. It wasn't until the 1980s, when Cold War secrecy began to thaw and historical interest in World War II, advanced weapons increased, that the Ho 229's story began to emerge publicly. Aviation historians discovered references to the Horten flying wing in captured German documents. Former Luftwaffe personnel began talking about the experimental programs they'd worked on. The Horten brothers, Reimar and Walter, were interviewed by aviation historians in the 1980s and 1990s. They'd remained in contact after the war and had continued discussing flying wing designs, though neither had the resources to build aircraft anymore. They were surprised and pleased to learn that their wartime work was being recognized and studied. Reimar Horten, in particular, was articulate about the technical challenges they'd faced and the solutions they'd devised. He explained the aerodynamic principles behind the swept wing configuration. He detailed the control system design. He discussed the materials choices and construction techniques. What emerged from these interviews was a portrait of two engineers driven by pure aeronautical passion who happened to be working for a monstrous regime. The Hortens weren't motivated by Nazi ideology. They were motivated by the challenge of making flying wings work. The war gave them resources and opportunity they wouldn't have had otherwise, but their ultimate goal was aeronautical excellence, not military victory. This presents a moral complexity that historians still grapple with. Can you separate the technology from the regime that produced it? Can you admire the engineering achievement while condemning the purposes it was intended to serve? There's no easy answer. But the Ho 229's story is incomplete without acknowledging this tension. In 2008, the Smithsonian Institution and the Northrop Grumman Corporation launched an extraordinary project. Rebuild the Horten Ho 229 using authentic materials and techniques, then test it to determine if it had stealth characteristics. This wasn't just historical curiosity. This was serious aerospace engineering research with implications for modern stealth technology. Because by the 2000s, aviation historians and engineers had begun asking a provocative question. Did the Horten brothers accidentally invent stealth technology in 1944? The question arose from analyzing the HO 229's construction and shape. Several characteristics suggested it might have a reduced radar cross-section. First, the flying wing configuration inherently presents a smaller profile to radar. There's no tail section reflecting radar waves back to the transmitter. There's no cylindrical fuselage creating strong radar returns. The smooth, continuous curves of the wing scatter radar energy in multiple directions, rather than reflecting it directly back. Second, the Ho 229's 32-degree wing sweep angles surfaces away from perpendicular to incoming radar waves. Radar reflection is strongest when surfaces are perpendicular to the radar beam. Angled surfaces reflect energy away from the source. Third, the construction materials were unusual. The plywood skin bonded with sawdust, mixed with charcoal and special adhesives containing significant amounts of iron oxide. These materials, it turned out, have radar-absorbing properties. They're not as effective as modern radar-absorbing materials, but they do reduce radar returns. Fourth, the engine intakes and exhausts were smoothly integrated into the wing, minimizing cavities that could create strong radar reflections. None of this was intentional. The Hortens chose the flying wing configuration for aerodynamic efficiency. They chose the wing sweep for stability and control. They used wood and plywood because aluminum was scarce. The iron oxide adhesives were chosen for their bonding properties, not radar absorption. But the cumulative effect of all these design choices was an aircraft with a significantly smaller radar signature than conventional aircraft of the same era. The 2008 project aimed to quantify this. Could the Ho 229 have evaded 1940s-era radar? The Northrop Grumman team, working with Smithsonian conservators, carefully measured and documented the surviving V-3 prototype. They created detailed CAD models of the entire aircraft. They analyzed the materials, measuring their electrical properties to determine how they would interact with radar waves. Then they built a full-scale replica of the center section using authentic materials: wood, plywood, steel tubing, and period-correct adhesives. This wasn't a flying replica. They weren't trying to recreate the flight characteristics. They were recreating the radar characteristics. The replica was taken to a radar testing range and subjected to radar illumination at frequencies typical of 1940s British chain-home radar systems, the primary air defense radar used by the Allies. The results were startling. The Ho 229 replica showed a radar cross-section approximately 40% smaller than a conventional fighter of similar size. More significantly, the testing revealed that British radar operators in 1945 would have detected the Ho 229 at about 80% of the range they would detect a conventional German fighter. Let's put that in concrete terms. If chain-home radar could detect a Messerschmitt Bf 109 at 100 miles, it would detect a Ho 229 at about 80 miles. That's a 20-mile advantage, several minutes of warning time lost. In air defense terms, that's significant. More importantly, the reduced detection range combined with the Ho 229's high speed would have created serious problems for Allied air defense. By the time radar detected an incoming Ho 229, it would be much closer to its target than conventional radars. Scrambling interceptors and vectoring them to intercept would have been much more difficult. The testing also revealed something the engineers hadn't expected. The Ho 229's radar signature varied significantly depending on the angle of observation. From certain angles, particularly nose-on and at shallow angles from below, the radar return was extremely small, approaching what modern engineers would call low observable. This wasn't true stealth. The aircraft wasn't invisible to radar, but it was significantly harder to detect and track than conventional aircraft. And this was achieved accidentally through design choices made for entirely different reasons. The implications were profound. The Horten brothers, working with 1940s technology and limited resources, had stumbled onto stealth principles that wouldn't be formally developed for another 30 years. They'd created an aircraft that was decades ahead of its time, not just in aerodynamics, but in low observable technology. Could this have changed the war? Almost certainly not. By the time the Ho 229 flew its first test flight, Germany had only 2 months left. Even if the program had continued and production aircraft had been built, there wouldn't have been time to produce enough to matter. Germany's defeat was inevitable by early 1945. But if the Ho 229 had been developed earlier, if it had been operational in 1943 or even 1944, that's a more interesting counterfactual. An operational Ho 229 fleet in 1943 could have seriously complicated Allied strategic bombing campaigns over Germany. The reduced radar detection range would have made it harder to provide early warning of interceptors. The high speed would have made it difficult for bomber escort fighters to engage effectively. The heavy armament would have been devastating against bomber formations. But this requires assuming several things that weren't true. It assumes the Jumo 004 jet engines would have been reliable enough for operational use. They weren't. It assumes Germany would have had the manufacturing capacity to produce Ho 229s in significant numbers while also producing Me-262s, conventional fighters, and other weapons. They didn't. It assumes enough trained pilots would have been available. They weren't. The Ho 229 was a technological marvel, but technology alone doesn't win wars. Germany lost World War II because of strategic factors far beyond any single weapon system's capabilities. Still, the stealth revelation changed how aviation historians viewed the Ho 229. It wasn't just an interesting experimental aircraft, it was a genuine glimpse into the future of aviation. A future that would take decades to arrive. The B-2 Spirit stealth bomber, which entered service in 1997, bears a striking resemblance to the Ho 229. Both are flying wings. Both use smooth, continuous curves to minimize radar returns. Both integrate engines into the wing structure. Both use composite materials with radar-absorbing properties. The B-2's designers studied the Ho 229 extensively during the development process. While the B-2 is far more sophisticated, it uses active radar-absorbing materials, computer-controlled fly-by-wire systems, and aerodynamic refinements the Hortens never dreamed of. The basic configuration principles are remarkably similar. Jack Northrop, who spent decades advocating for flying wing aircraft, died in 1981. Shortly before his death, he was shown classified footage of the B-2 development aircraft. Northrop, who was wheelchair-bound and could no longer speak due to a stroke, reportedly wrote on a notepad, "Now I know why God has kept me alive for the last 25 years." He'd lived to see his flying wing vision vindicated, and implicit in that vindication was the validation of the Horten brothers' work 40 years earlier. The Ho 229's story is incomplete without understanding that the Horten brothers weren't the only engineers pursuing flying wing technology during World War II. There were parallel developments in other countries, though none reached the same advanced stage as the Ho 229. In the United States, Jack Northrop's company had been building flying wing aircraft since the 1930s. The N-1M, which first flew in 1940, was a small experimental flying wing powered by piston engines. It was strictly a research aircraft, too small and underpowered for military use, but it validated the basic aerodynamic principles. During the war, Northrop proposed a flying wing fighter to the U.S. Army Air Forces. The design was similar in concept to what the Hortens were working on, a jet-powered flying wing with heavy armament and high performance. But the proposal was rejected. American military planners were conservative. They wanted proven conventional designs, not experimental configurations. Northrop persisted. By 1944, he'd secured a contract to develop the XB-35, a massive flying wing bomber powered by piston engines. The XB-35 had a wingspan of 172 feet, more than 3 times the HO 229's wingspan. It was designed to carry 10,000 pounds of bombs across intercontinental ranges. The first XB-35 didn't fly until after the war ended, in June 1946, and it immediately demonstrated the problems inherent in large flying wings. Stability and control issues were severe, and the contra-rotating propellers caused intense vibrations that threatened to shake the aircraft apart. The XB-35 program led to the YB-49, a jet-powered version that replaced the propellers with 8 jet engines. The YB-49 first flew in October 1947. It was impressively fast, cruising at over 400 miles per hour, but stability problems persisted. The aircraft was challenging to fly, and landing was particularly difficult. More problematically, the flying wing configuration made it nearly impossible to aim bombs accurately. Without a conventional fuselage, there was no natural reference line for the bombardier. The YB-49's bombing accuracy was significantly worse than conventional bombers. This, combined with the ongoing stability issues, led to the program's cancellation in 1949. Jack Northrop believed the cancellation was political, that the Air Force wanted to buy the Convair B-36 bomber instead and used the YB-49's problems as justification. There's some evidence supporting this theory, but it's also true that the YB-49 had genuine technical problems that wouldn't be solved for decades. The point is this: even with significant resources, a dedicated design team, and access to advanced technology, American engineers in the late 1940s couldn't make large flying wings work reliably. Yet the Horten brothers, working with limited resources in a collapsing regime, had created a smaller flying wing that actually flew successfully, at least until the engine failure. This speaks to the Hortens' engineering talent. They'd solved problems through clever design and careful aerodynamic analysis that American engineers with more resources struggled to solve. In Britain, there was also flying wing research during the war. The Armstrong-Whitworth AW-52, a jet-powered flying wing research aircraft, was designed in 1943 but didn't fly until 1947. Like the American designs, it encountered severe stability problems. The program was eventually abandoned. The Soviets captured some German flying wing research at the war's end, including documents and possibly some hardware from early Horten designs. They experimented with flying wing concepts in the late 1940s and early 1950s, but like the Western Allies, they couldn't solve the stability and control problems satisfactorily. Soviet flying wing projects were cancelled in favor of conventional configurations. So why were the Hortens more successful? Several factors. First, they focused on a smaller aircraft. The Ho 229 had a wingspan of 16 meters. American and British flying wing projects were much larger. The XB-35's wingspan was over 50 meters. Stability and control problems scale with size. A smaller flying wing is inherently easier to stabilize than a larger one. Second, the Hortens had been working on flying wing designs since the early 1930s. They had 15 years of experience with gliders and powered flying wings before they attempted the Ho 229. They understood the aerodynamic problems intimately and had developed solutions through iterative design. Third, they made clever design choices. The 32-degree wing sweep, the specific airfoil sections, the eleven control system. These weren't guesses. They were carefully calculated solutions to known problems. Fourth, they had realistic performance goals. The Ho 229 was designed to meet Hitler's 1,000 requirement, but that was for a fighter bomber role. They weren't trying to build a heavy bomber like the XB-35. The smaller size and lighter weight made the engineering challenges more manageable. But all of this raises an interesting question. If the Hortens were so successful, why didn't flying wings become the standard configuration for jet aircraft? The answer is that the problems the Hortens solved for a small fighter bomber don't scale to other roles. Large flying wings, as American research demonstrated, have severe stability and control issues. Modern fly-by-wire computer systems can compensate for these issues, but such systems didn't exist in the 1940s or 1950s. Additionally, conventional aircraft configurations work well enough for most purposes. The efficiency gains of flying wings are real, but not overwhelming for many roles. A conventional fighter or bomber might have 10% more drag than an equivalent flying wing, but that's acceptable if the conventional design is easier to build, maintain, and fly. Flying wings make sense for specific roles where efficiency is paramount. Long-range strategic bombers benefit enormously from the reduced drag, hence the B-2 spirit. Unmanned aircraft, where the pilot doesn't need visibility from a conventional cockpit, can use flying wing configurations effectively, hence modern stealth drones. But for general aviation purposes, the conventional configuration remains dominant simply because it works well enough and is easier to implement. The Ho 229 was ahead of its time precisely because it was designed for a role, fast jet fighter bomber, where the flying wing configuration's advantages outweighed its disadvantages. And it was developed by engineers who understood the configuration deeply enough to make it work. After the war, the Horten brothers' lives took different paths, though they remained in contact and continued discussing flying wing designs. Reimar Horten, the younger brother and the primary aerodynamicist, was captured by Allied forces in May 1945. He was interrogated about the Ho 229 and other Horten flying wing projects. The interrogators were impressed by his technical knowledge, but determined he wasn't a candidate for Operation Paperclip. He was released and returned to civilian life in Germany. Post-war Germany was devastated, employment was scarce, aviation work was prohibited under Allied occupation rules. Germany wasn't allowed to build aircraft of any kind. Reimar worked various jobs to survive, but his passion remained flying wings. In 1948, he emigrated to Argentina. The Argentine government, under President Juan Perón, was actively recruiting German scientists and engineers. Argentina wanted to develop an indigenous aviation industry, and German expertise was welcomed. No questions asked about wartime activities. Reimar Horten found work with the Instituto Aerotecnico in Córdoba, Argentina. Finally, he could work on aircraft again. And naturally, he proposed flying wings. Between 1948 and the early 1960s, Reimar designed and helped build several flying wing aircraft in Argentina. The IAE-34 Clen Antu was a flying wing glider completed in 1948. The IAE-37 was a jet-powered flying wing research aircraft that flew in the early 1950s. The IAE-38, a jet-powered fighter-bomber project based heavily on the Ho 229 concept, was designed but never completed. None of these projects achieved the success of the Ho 229. The Argentine aviation industry lacked the resources and technical sophistication to fully support advanced aircraft development. But Reimar persisted, refining his flying wing concepts and training Argentine engineers in flying wing aerodynamics. He remained in Argentina for the rest of his life. In interviews conducted in the 1980s and 1990s, Reimar spoke extensively about the Ho 229 and flying wing theory. He was generous with his knowledge, answering technical questions in detail and providing insights into the design decisions he and Walter had made. Reimar Horten died in 1994 at the age of 79. He never saw the B-2 bomber become operational. It was still in development when he died. But he knew about the program and understood that his flying wing work had contributed to modern stealth aircraft development. Walter Horten, the older brother and a combat pilot during the war, remained in Germany after the war. He'd survived numerous combat missions, flying Bf-19s and other fighters. After the war, he couldn't fly. Allied occupation authorities prohibited Germans from flying aircraft, but he worked in various engineering roles. When restrictions on German aviation were lifted in the 1950s, Walter returned to aviation, though not in flying wing design. He worked for several German aerospace companies in conventional aircraft roles. But he maintained his interest in flying wings and stayed in touch with Reimar in Argentina. Walter provided technical information to aviation historians researching the Ho 229. His interviews, combined with Reimar's, provided crucial insights into the development of the Ho 229 and earlier Horten flying wings. Without their cooperation, much of the technical detail would have been lost. Walter Horten died in 1998 at the age of 84. By then, the Ho 229 had been recognized as a significant milestone in aviation history, and the Horten brothers' contributions were being studied seriously by aerospace engineers worldwide. The brothers never expressed regret about working for Nazi Germany, which has troubled some historians. When asked about the moral implications of developing weapons for the Third Reich, their responses were typically technical rather than moral. They'd been engineers focused on solving aeronautical problems. They hadn't been involved in atrocities or war crimes. They'd built aircraft because that's what they knew how to do. This perspective is understandable but incomplete. They benefited from a system that was committing genocide. Their work supported that system's military efforts. Moral responsibility isn't negated by technical focus. Yet it's also true that their work transcended the regime they served. The flying wing concepts they developed continue to influence aviation. The Ho 229 proved that jet-powered flying wings were practical, paving the way for modern stealth aircraft. Aerospace engineers today study Horten aerodynamics to understand flying wing stability and control. In some ways, the Horten brothers' legacy is similar to Wernher von Braun's. Von Braun developed the V-2 ballistic missile for Nazi Germany, a weapon that killed thousands of civilians and was built using slave labor. After the war, he worked for the United States and developed the rockets that put Americans on the moon. His legacy is complicated. Visionary rocket scientist or Nazi collaborator. The Horten brothers didn't achieve von Braun's post-war prominence, but the moral questions are similar. Do we celebrate the technology while acknowledging the context? Do we study the engineering while condemning the regime? There's no simple answer. What's clear is that the Ho 229 was a genuine engineering achievement. It pushed the boundaries of what was possible with 1940s technology. It proved concepts that wouldn't be fully validated for decades. And it influenced aviation development in ways the brothers couldn't have imagined. In 2009, the Smithsonian's National Air and Space Museum began a comprehensive restoration project on the Ho 229 V3 prototype. The aircraft had been in storage since 1950, carefully preserved but not displayed. The restoration would prepare it for eventual public display while also providing opportunities for detailed technical analysis. The restoration team faced unique challenges. The Ho 229 was built using mixed materials, steel tubing, wood, plywood, that aged differently. Some wooden components had deteriorated significantly over 60 years. The plywood skin had separated in places. Metal parts showed corrosion, but the restoration philosophy was conservative. Preserve original materials wherever possible, stabilize the structure to prevent further deterioration, but don't rebuild or replace components unless absolutely necessary. This aircraft was a historical artifact, not a flying restoration. The goal was to preserve it as it was captured in 1945. As conservators carefully disassembled and examined components, remarkable details emerged. The craftsmanship was extraordinary. Despite being built in a workshop with limited resources in late 1944, the construction quality was high. Joints were carefully fitted, welds were clean. The plywood skin was precisely shaped. The steel tubing framework showed evidence of careful engineering. Load paths were efficiently designed. Structural members were sized appropriately for the stresses they would encounter. This wasn't crude wartime expedient construction. This was thoughtful engineering executed competently. The wing's internal structure revealed how the Horten solved the challenge of integrating everything into a wing shape. The center section contained spaces for the cockpit, the two engines, fuel tanks, and landing gear, all arranged to maintain proper center of gravity and structural integrity. It was like a three-dimensional puzzle, with each component positioned carefully to make everything fit while maintaining aerodynamic shape. The elevon control system showed clever mechanical design. The linkages that connected the control stick to the elevons were arranged to provide proper control surface movements, while accounting for the wing's sweep and the elevon's positions. Without computer-aided design, the Hortens had worked this out, using manual calculations and careful mechanical design. Modern aerospace engineers who examined the Ho 229 during restoration were impressed. One engineer from Northrop Grumman commented that the Hortens had solved control system problems that American engineers struggled with 15 years later when developing the YB-49. The solutions were elegant and practical. The adhesive used to bond plywood panels proved particularly interesting. Analysis showed it contained significant amounts of charcoal and iron oxide. This wasn't standard aircraft adhesive. Post-war research determined this specific formulation had radar-absorbing properties, the basis for the stealth testing discussed earlier. But here's the question that has never been definitively answered. Did the Hortens intentionally choose this adhesive for its radar-absorbing properties, or was it simply what was available? Reimar Horten, in interviews before his death, gave conflicting answers. Sometimes he suggested they'd considered radar absorption. Other times, he indicated the adhesive choice was based on availability and bonding strength. The truth may be somewhere in between. They may have been aware of radar-absorbing properties but considered it a secondary benefit, not a primary design goal. The engines, or rather the engine mounts, since no engines were installed in the V3, showed how the Hortens planned to integrate the Jumo 004s. The mounting system allowed relatively easy engine removal and installation, important for maintenance since early jet engines required frequent servicing. The intake and exhaust ducting was smoothly contoured to minimize aerodynamic losses. One detail that surprised modern engineers was the simplicity. The Ho 229 didn't use complex systems or exotic materials. It was fundamentally conventional engineering applied cleverly to an unconventional configuration. This suggested that flying wings weren't as difficult as post-war development suggested, or that the Hortens were exceptionally talented engineers who made it look easier than it was. The restoration also revealed evidence of the rushed nature of late-war German production. Some components showed improvisation. Standard fasteners were used where custom fittings would have been better. Some structural members were sized larger than necessary, suggesting conservative engineering when precise calculations weren't possible. Yet despite these wartime compromises, the overall design was sound. If the V3 had been completed and flown, experts believe it would have performed similarly to the V2, fast, maneuverable, and effective. By 2011, the restoration had progressed to the point where the Ho 229 could be displayed. The Smithsonian's Udvar Hazy Center, an extension of the Air and Space Museum located near Dulles Airport in Virginia, prepared a special exhibit. The Ho 229 V3 was positioned prominently, suspended from the ceiling as if in flight. Interpretive panels explained the aircraft's history, technical innovations, and significance. Visitors could see the smooth flying wing shape, the swept wings, the engine openings, and imagine what this aircraft might have meant if it had been deployed operationally. The exhibit also addressed the moral complexity. It acknowledged that the Ho 229 was developed by Nazi Germany, a regime responsible for genocide and aggressive war. It noted that the aircraft's purpose was to strike Allied targets and kill Allied personnel. But it also explained the technical innovations and the aircraft's influence on post-war aviation development. This balanced approach, acknowledging both the historical context and the technical achievement, is essential. We can't sanitize history or pretend that brilliant engineering wasn't created in service of terrible causes. But we also can't ignore the engineering simply because of its origins. The Ho 229 represents both human ingenuity and human destructiveness. It's a reminder that technology is neutral. How it's used determines whether it's beneficial or harmful. The Ho 229's influence on post-war aviation development is difficult to quantify precisely, but it's clearly significant. Most obviously, the Ho 229 influenced American flying wing research. When Jack Northrop's engineers were developing the YB-49 in the late 1940s, they had access to captured Ho 229 documents and could examine the V-3 prototype. While the YB-49 was a much larger aircraft with different design parameters, some of the control system solutions the Hortens developed informed American approaches. More broadly, the Ho 229 demonstrated that jet-powered flying wings were practical. Before the Ho 229 flew, flying wings were theoretical or had only flown with piston engines. The Ho 229 proved the concept could work with jets, validating the configuration for high-performance applications. This validation was important for maintaining interest in flying wing research during the decades when stability and control problems seemed insurmountable. Engineers could point to the Ho 229 and say, "They made it work with 1940s technology. We can make it work with modern systems." The stealth revelation in 2008 added another dimension to the Ho 229's legacy. Modern stealth aircraft designers study the Ho 229 to understand early radar cross-section reduction principles. While modern stealth uses far more sophisticated techniques, the basic concepts, smooth contours, angular surfaces deflecting radar, radar-absorbing materials, are all present in the Ho 229, even if accidentally. The B-2 Spirit bomber is the most visible example of Ho 229 influence. The resemblance is striking. Both are flying wings with swept leading edges, both integrate engines into the wing, both use smooth contours throughout. The B-2's designers explicitly studied the Ho 229 during development. But the influence extends beyond just the B-2. Modern unmanned combat air vehicles, many of which use flying wing configurations, owe a debt to the Ho 229. The X-47B, an experimental carrier-based UCAV, is a flying wing. The BAE Taranis, a British stealth drone demonstrator, is a flying wing. The Russian Okhotnik UCAV is a flying wing. These modern aircraft use fly-by-wire computer control systems to solve the stability problems that plagued early flying wings. But the basic aerodynamic configuration traces directly back to pioneers like the Horten brothers and Jack Northrop. In academic aerospace engineering, the Ho 229 is studied as a case study in flying wing design. University courses on aircraft design often include analysis of the Ho 229's aerodynamics. Research papers have been published analyzing its stability characteristics, control system design, and structural engineering. The aircraft has also entered popular culture. The Ho 229 appears in documentaries about secret Nazi weapons. It features in video games about World War II aviation. It's mentioned in alternative history novels exploring what might have happened if Germany had deployed advanced weapons earlier. Some of this popular culture treatment borders on sensationalism, the Nazi superweapon narrative that exaggerates the Ho 229's potential impact. But it's also kept the aircraft in public consciousness and sparked interest in aviation history. Model aircraft companies produce Ho 229 kits. RC aircraft enthusiasts build flying-scale models. Some of these models are quite sophisticated, using modern materials and control systems to make the flying wing configuration work. These hobby projects, in a small way, continue the work the Horten brothers began. Educational programs use the HO-229 to teach principles of aerodynamics and engineering design. The aircraft presents interesting problems. How do you control an aircraft without a tail? How do you integrate engines into a wing? How do you balance competing requirements for stability, control, and performance? These aren't just historical questions, they're relevant to modern aircraft design, especially for unconventional configurations. The HO-229 also serves as a cautionary tale about technology and ethics. It's a reminder that brilliant engineering can be created for terrible purposes. The aircraft's beauty, and it is aesthetically striking, doesn't erase the fact that it was designed to deliver bombs to civilian targets. This tension between technological achievement and moral context is important. We should study the HO-229's engineering. We should appreciate the innovations. But we should also remember why it was built and what it was intended to do. In the broader history of aviation, the HO-229 occupies a unique place. It's not as famous as the Wright Flyer or the Spirit of St. Louis. It's not as historically significant as the Supermarine Spitfire or the Boeing B-17. It never achieved operational status, never flew combat missions, never changed the course of the war. But it represents a moment when the future of aviation was visible, even if the technology to fully realize that future didn't yet exist. It showed what was possible, even if it would take decades to make it practical. The HO-229 is a bridge between the propeller era and the jet age, between conventional aircraft and stealth technology, between World War II desperation and Cold War innovation. It's a glimpse of the future, frozen in 1945, waiting for the rest of aviation to catch up. Any discussion of advanced World War II German weapons inevitably leads to alternative history speculation. What if the HO-229 had been operational earlier? What if the engine reliability problems had been solved? What if Germany had deployed hundreds of HO-229s instead of just building prototypes? These questions are popular in alternative history forums and speculative documentaries. But answering them requires understanding the realities of Germany's strategic situation and the limitations of the HO-229 as a weapon system. Let's start with a realistic scenario. Suppose the HO-229 program had been prioritized in 1943 instead of 1944. Suppose Reimar and Walter Horten had been given substantial resources, skilled personnel, and production priority. Suppose the design had been refined, tested thoroughly, and put into production by mid-1944. What then? First, consider the numbers. Germany's aircraft production in 1944 was approximately 40,000 aircraft total, including all types: fighters, bombers, transports, trainers. Of these, about 25,000 were fighters. The Messerschmitt Me 262 jet fighter, which was prioritized and did enter production, had about 1,400 examples built before the war ended. Even with priority, the HO-229 might have achieved similar production numbers, perhaps 1,000 to 2,000 aircraft. This assumes solving the engine reliability problems, establishing production infrastructure, training production workers, and maintaining supply chains while Germany was being bombed relentlessly. 1,000 HO-229s sounds significant. But consider, the Luftwaffe was facing combined Allied air forces with tens of thousands of aircraft. The USAAF alone had over 13,000 combat aircraft in Europe by 1944. The RAF had thousands more. The Soviets had massive air forces on the Eastern Front. Even if every HO-229 achieved a favorable kill ratio against Allied aircraft, say 5-1, the mathematics don't favor Germany. 1,000 HO-229s destroy 5,000 Allied aircraft. The Allies replace them and keep coming. Germany doesn't have the industrial capacity, fuel, or trained pilots to sustain operations. But let's consider tactical effects. The HO-229's high speed and reduced radar signature would have complicated Allied bomber operations over Germany. Bomber formations relied on early warning, from radar to scramble fighter escorts. If German interceptors could approach undetected or be detected at reduced range, they'd have tactical advantages. Heavy bomber formations, like the American B-17 and B-24s, were vulnerable to fighter attack, especially before long-range escort fighters became available. A fast, heavily armed fighter like the Ho 229 could have inflicted serious casualties. However, by late 1943 and early 1944, the Allies had developed tactics to deal with fast German interceptors. Fighter escorts increased. Bomber defensive formations were refined. Bombing missions were coordinated with fighter sweeps to suppress German defenses. The Ho 229 would have been another threat to adapt to, but probably not a game-changer. The Allies adapted to the Me-262, which was arguably a more significant threat since it was actually deployed in numbers. They would have adapted to the Ho 229. On the bombing role, Hitler's original vision of using it to strike Britain, the Ho 229 would have faced different challenges. The aircraft's range was about 1,000 kilometers, which meant it could reach London from bases in occupied France or the Low Countries. Its speed would make interception difficult. Its bomb load was modest, but sufficient for tactical strikes. But by 1944, the Allies controlled the air over their own territory. British air defences were sophisticated. Radar coverage was comprehensive. Night fighters were experienced and effective. Even fast, low-observable targets could be engaged once detected, and the HO 229 wasn't truly stealthy, just harder to detect. Moreover, strategic bombing campaigns require sustained operations with large numbers of aircraft. A few dozen Ho 229s conducting raids would be a nuisance, not a strategic threat. Germany would need hundreds of bombers conducting regular missions to significantly impact Allied operations. This was beyond German industrial and logistical capacity by 1944. The most realistic alternative history scenario is that an operational Ho 229 force would have been tactically effective but strategically irrelevant. German pilots would have achieved local successes. Allied bomber crews would have faced a new, challenging threat. Air combat over Germany would have been even more deadly for both sides. But Germany would still have lost the war. The Ho 229, however advanced, couldn't overcome the fundamental strategic realities. Overwhelming Allied industrial capacity, secure Allied logistics, multi-front pressure from American, British and Soviet forces, and Germany's own resource constraints and industrial destruction. Advanced weapons can win battles. They rarely win wars, especially when the strategic fundamentals favor the other side. There's another alternative history scenario worth considering. What if the Horten brothers had been working for the Allies instead of Germany? Imagine if Reimar and Walter Horten had emigrated to Britain or America in the 1930s. Imagine if they'd proposed flying wing designs to the RAF or USAAF. Would their ideas have been accepted? Probably not, at least not initially. Allied air forces were conservative. They wanted proven designs, not experimental configurations. Jack Northrop struggled to get American interest in flying wings throughout the 1930s and 1940s, despite being an American citizen with an established company. The Horten brothers would have faced even more resistance as German immigrants proposing radical designs. They probably would have ended up working on conventional aircraft or in research roles. Their flying wing concepts shelved until the jet age made them relevant. This highlights an uncomfortable truth. Innovation often flourishes in desperate circumstances. Nazi Germany, facing overwhelming Allied advantages, was willing to gamble on unconventional weapons. The Allies, confident in their conventional superiority, had less incentive to pursue radical designs. The Ho 229 exists because Germany was losing and needed miracles. Ironically, this desperation created conditions where brilliant but unconventional ideas could be developed. In a different context, the Horten brothers might never have had the opportunity to build their jet-powered flying wing. March 2, 1945. Erwin Ziller dies in a field near Oranienburg. The Horten Ho 229V-2 prototype lies in burning wreckage. The dream of the jet-powered flying wing seems to die with it. But 75 years later, we can see that the dream didn't die. It evolved, it influenced, it inspired. The B-2 Spirit bomber flying over Afghanistan in the 2000s. The X-47B demonstrator landing on an aircraft carrier. The Northrop Grumman RQ-180 surveillance drone orbiting at the edge of space. All of them are descendants, in some way, of the radical black wing the Horten brothers created in a workshop in Nazi Germany. The Ho 229 story is ultimately about the persistence of ideas. Good engineering concepts don't die even when the regimes that produce them collapse. The flying wing configuration made aerodynamic sense in 1944. It makes sense in 2024. The fundamental physics haven't changed. But the story is also about timing and technology. The Horten brothers were ahead of their time. They had the vision and skill to design a jet-powered flying wing, but the technology to make it fully practical. Reliable jet engines, computer flight control systems, advanced materials wouldn't exist for decades. They were like Leonardo da Vinci sketching flying machines in the 15th century. The concepts were sound, the engineering was thoughtful, but the supporting technology to make it work didn't exist yet. Yet their work mattered. It proved the concept. It validated the configuration. It provided a foundation for later engineers to build on. The Ho 229 also reminds us that technology emerges from complex contexts. The aircraft was born from Nazi Germany's desperation, built using slave labor and scarce materials, intended to deliver bombs to civilian targets. We can't celebrate it without acknowledging this reality. But we can study it, we can learn from it, we can appreciate the engineering achievement while understanding the moral context. Technology itself is neutral. What matters is how we use it and why we create it. The Horten brothers were visionary engineers. They were also participants in a genocidal regime's war effort. Both things are true. History is rarely simple. Today, the Ho 229 V3 sits in the Smithsonian's Udvar-Hazy Center. Visitors walk beneath it, looking up at the smooth black wing, marveling at its futuristic appearance. School children learn about flying wing aerodynamics. Aerospace engineers study its design. History enthusiasts contemplate what might have been. The aircraft that was built to be a weapon has become a teacher. The prototype that never flew in combat now flies in imagination, inspiring new generations of engineers and aviation enthusiasts. Reimar and Walter Horten dreamed of flying wings from their youth. They pursued that dream through gliders, through war, through defeat, and into the post-war years. Reimar continued designing flying wings in Argentina. Walter consulted on aviation projects in Germany. Neither ever stopped believing in the flying wing concept. They lived long enough to know their work mattered. They saw the B-2 bomber program announced. They knew about stealth technology development. They understood that the radical ideas they'd pursued in the 1930s and 1940s had become mainstream by the 1990s. In one of his final interviews in 1993, Reimar Horten reflected on the Ho 229. We were trying to solve problems that wouldn't be fully solved for 50 years. We knew flying wings were the future. We just didn't have the technology to make them perfect. But we showed it could be done. That was enough. It was enough, because showing something can be done, even imperfectly, is sometimes all that's needed. The next generation of engineers can refine it. They can improve it. They can perfect it. That's how technology advances, not in sudden leaps, but in accumulated progress. Each generation builds on what came before. The Ho 229 was a step forward, a significant step, taken in dark circumstances, but a step nonetheless. And every B-2 that flies today, every flying wing drone that patrols the skies, carries a small piece of the Horten brothers' vision. The race for the jet age didn't end in 1945. It's still ongoing. Jets got faster, then supersonic, then hypersonic. Designs got more sophisticated, materials got stronger and lighter, control systems got smarter, but some principles remain constant. Reduce drag, integrate components efficiently, design for the mission. These were the Horten brothers' principles in 1944. They're still the principles aerospace engineers follow today. The Ho 229 was Hitler's flying wing, designed to serve a dying regime's desperate gamble. But it became humanity's flying wing, a contribution to aviation knowledge that transcended its origins. That's the final paradox of the Ho 229. It was created for the worst reasons, but represents some of humanity's best qualities: ingenuity, persistence, vision, and the drive to solve seemingly impossible problems. The smooth black wing hanging in the Smithsonian is a reminder of what humans can create when we apply our intelligence and skill, a reminder of how that creativity can serve both noble and terrible purposes, and a reminder that good ideas outlast bad regimes. 75 years after Erwin Ziller died in that field near Oranienburg, the Ho 229 still speaks to us about the past, about what might have been, and about the future of aviation that the Horten brothers glimpsed but never lived to see fully realized. The race for the jet age continues. Flying wings are no longer radical experiments, they're operational reality. Stealth technology is proven, high-speed jet aircraft are commonplace. We won that race, humanity won that race, and two brothers from Bonn, Germany, obsessed with flying wings since their youth, helped show us the way. That's the legacy of the Horten Ho 229. Not a weapon that changed the war, not a superweapon that gave Nazi Germany victory, but an idea, a radical, brilliant, ahead-of-its-time idea that helped shape the future of flight. And that's worth remembering. If you want to see the Horten Ho 229 V3 for yourself, it's on permanent display at the Smithsonian National Air and Space Museum's Stephen F. Udvar-Hazy Center in Chantilly, Virginia, near Washington Dulles Airport. The aircraft is suspended from the ceiling in the museum's main hangar, positioned as if in flight. It's displayed alongside other significant World War II aircraft: American, British, Japanese, and German. The Ho 229 holds its own among them, its sleek, futuristic profile standing out even among famous warbirds. Seeing it in person is revelatory. Photographs don't capture the scale or the smoothness of the lines. The wing sweep is more dramatic than pictures suggest. The integration of all components into the wing structure is more impressive when you can walk around and view it from different angles. Information panels explain the aircraft's history, the Horten brothers' story, and the technical innovations. The museum's treatment is balanced, acknowledging both the engineering achievement and the historical context of Nazi Germany's weapons development. The Ho 229 isn't the only captured German aircraft at Udvar-Hazy. The museum also displays an Arado R-234 jet bomber and a Heinkel He 219 night fighter, among others. But the Ho 229 is perhaps the most striking, the most radical in appearance, the most obvious glimpse into aviation's future. Visitors often spend significant time studying the Ho 229. Aerospace engineers examine the control surfaces and structural details. History buffs photograph it from every angle. Children ask their parents why it looks so different from other airplanes. It's become one of the museum's most popular exhibits, precisely because it challenges expectations. Most World War II aircraft look similar, conventional layouts with minor variations. The Ho 229 looks like it belongs in a science fiction movie, not a 1945 aircraft hangar. For aviation enthusiasts, the Ho 229 is a pilgrimage destination. It's one of the most significant aircraft that was never produced in quantity. It represents roads not taken, futures that might have been, and technologies ahead of their time. The Smithsonian Conservation Team continues to monitor the aircraft's condition. Wood and composite materials deteriorate over time, even in climate-controlled storage. Periodic inspections ensure the HO 229 remains stable and preserved for future generations. There's been occasional discussion of attempting to build a flying replica, a Ho 229 reproduction, using modern materials and engines, equipped with modern flight control systems to solve the stability problems that challenged the original. Several groups have proposed such projects over the years. None have come to fruition, largely due to cost and the complexity of recreating 1940s German construction techniques. But the idea persists. Imagine seeing a jet-powered flying wing, built to 1944 specifications but equipped with modern systems, actually flying. It would be a remarkable tribute to the Horten brothers' vision. Until that happens, if it ever does, the V3 prototype at Udvar-Hazy remains the closest most people will get to experiencing the Ho 229. And for aviation history, that's probably appropriate. The Ho 229 is a museum piece for good reasons. It represents a moment in time when technology and desperation intersected. It's a historical artifact that should be preserved and studied, not a design that should be reproduced and flown. But standing beneath it, looking up at the smooth black wing, you can imagine. Imagine Erwin Ziller climbing into the cockpit on March 2nd, 1945. Imagine the Jumo jet spooling up. Imagine that radical flying wing lifting into the sky over war-torn Germany. And you can wonder what might have happened if the program had continued. Wonder how aviation history might have unfolded differently. Wonder what the Horten brothers might have achieved if they'd had more time, more resources, and been working for different purposes. The Ho 229 invites imagination, it demands contemplation, and it rewards study. That's why it matters. Not because it changed the war, it didn't. Not because it was a superweapon, it wasn't. But because it represented possibility. The possibility of radical innovation. The possibility of technical excellence even in desperate circumstances. The possibility of glimpsing the future while trapped in the present. 75 years after its story ended in a burning field near Oranienburg, the Horten Ho 229 still flies. Not literally, but in inspiration, in influence, in the imaginations of everyone who sees it and wonders, what if? That's the power of visionary engineering. It transcends the moment of its creation. It outlives its creators. It influences generations that follow. The Horten brothers' flying wing was born in Nazi Germany's final desperate years. But it belongs to aviation history's entire timeline, connecting the past to the present and pointing toward the future. And that future, filled with flying wing stealth bombers, unmanned aerial vehicles, and aircraft configurations we haven't yet imagined, owes a debt to two brothers who dared to dream differently. The race for the jet age began with pioneers like the Horten brothers. It continues today with engineers pushing boundaries in new directions. And somewhere in that continuum, the HO 229 sits suspended, literally in the Smithsonian, figuratively in aviation history, as a reminder of how far we've come and how much was glimpsed, even briefly, decades before we thought possible. Hitler's flying wing became humanity's lesson, about innovation, about persistence, about vision, and about the complex relationship between technology, context, and legacy. That's the story of the Horten Ho 229, a story that began with two brothers' dreams, passed through Nazi Germany's nightmare, and emerged into history as something more than either, a genuine contribution to human knowledge about flight. And that story continues, every time someone looks up at that black wing hanging in the Smithsonian and thinks incredible, beautiful, terrifying, brilliant, all true, all part of the same complex legacy. The Ho 229 isn't just an aircraft, it's a question, a challenge, an inspiration, and a warning. It asks, what else is possible? It challenges, push boundaries, take risks, think differently. It inspires, radical ideas can work, vision matters, persistence pays off. And it warns, technology serves human purposes, good or evil. Context matters, ethics matter. All of these lessons suspended in a smooth black wing, waiting for anyone willing to look up and learn. That's the final legacy of the Horten Ho 229. Not conquest, not victory, not terror from the skies, but knowledge, inspiration, and a glimpse of futures both dark and bright, depending on how we choose to use the technologies we create. The Horten brothers chose to build a flying wing. History chose what it would mean. We choose what lessons we draw from it, and the smooth black wing hangs there still, in a museum in Virginia, silent witness to all of it. Past, present, future. Hitler's flying wing, the Horten brothers' dream, humanity's inheritance. The race for the jet age continues. The Ho 229 showed us one possible path. We've taken it, adapted it, and made it our own. And somewhere, perhaps, Reimar and Walter Horten are watching, satisfied that their vision, born in gliders in the 1930s, refined through war in the 1940s, vindicated in the jet age, finally came to fruition. The flying wing flies, not as they built it, but as they imagined it. That's enough. That's legacy. That's history. The smooth black wing hangs suspended, forever frozen in flight, forever pointing toward tomorrow.